So just stick with us for a few more here, and we hope we got some good content for you here. So my name is Tommy Ethier. I was the team lead for this project, and this is the rest of my team.
I'm Sam Peterson, I was the developer.
Corey Higbert, I was the Linux admin on the project.
Our fourth team member, Dylan Widener, could not be here. He's actually got called to serve with the National Guard, so we thank him for the work on this project, and he's really sad that he couldn't be here, but he's with us in spirit. So as I said earlier, this is our 2019 Spring Capstone project. We were sponsored by Dell EMC. That team is comprised of Jake Hallis, Steve Hull, and Jacob Bedford. Only one of them could be with us here today, so we thank him for being here. But the main points of this project is we're doing more open source, just like Target was, a lot of open networking and switching from Windows to Linux. So without further ado, we'll get started. If the clicker works. Maybe not. Managed Services lost access to an entire production server. This was by way of a failed switch port. So you're going to see Corey and Sam simulate this by closing out a switch port, making it fail, and the customer has no access to that production server, as you can see by the green line on the topology.
Alright, to begin, we're getting connected to our production server. Next, we're going to show you the containers we have configured in there. And amongst those, we're going to go into the SQL container. And then we're going to show you we're going to select our testDB database. And then we're going to show you what's in the customers table within that database. Now we're going to add a new row of data, which basically just consists of a first name, last name, and a phone number. Now we're going to verify that the row is in there, and it is. You can see in the bottom there. Next, we're going to exit out of our SQL container, and then we're going to run the following command, which is going to synchronize our changes to make sure that they're applied to the disaster recovery device.
The disaster recovery device is actually highlighted by the green brackets on the right side of the topology.
All right. Next, we're going to go on into our production side switch, and then we're going to kill the port that's providing the bridge connection between the server and the switch. Next, we're going to ping to verify that the connection has been broken.
So you can see our production side SQL container is down now as we can't ping that server. So now we're going to replicate, well, we already replicated all the information across. So we're going to go onto the disaster recovery side and show that we can see that new information over now. So we'll just SSH over to the disaster recovery server. We'll kind of do the same thing as we did on the other server here. We'll attach into the SQL container. And then for those changes to actually take effect, you have to restart the MySQL service. So the MySQL service will be restarted on a daily basis, as well as that rsync command we ran on the other server, that's going to run on a daily basis as well. So just use a systemctl restart MySQL command here. And then once that's done, we'll go into that database and we can show that the new information is in there. And we use the same test database, everything should be replicated exactly the same here. And you can see the fourth row is now on the disaster recovery container as well.
And again, the customer automatically failed over to that simulated WAN to get to the disaster recovery side, to get to the disaster recovery device. And it might have taken a couple minutes for Corey to do it here, but for the customer, it would be almost instantaneous that it would fail over for them because the backups would happen prior to any failure happening for them. So in the third scenario, it's kind of like a apocalypse scenario. The entire production site is down. This could be because of some catastrophic event, flooding, a fire, that kind of thing. And the customer has no access to anything on our production site. So we're going to show you how our disaster recovery will save them time and money by automatically failing over to the disaster recovery site.
So to show this one, we have a web server running on both production servers in their own separate containers. We have one which is address 215 and the other one is 225. As you know from the last scenario, we took down the one switch port for one of the production servers already, which is running the 215, so you can kind of see this one's already working, but we'll take down the other server as well, just so we can pull down the whole production side. So that'll be right on the switch. Similar to the other command, we're going to remove the other port going to the production side. And here, like we showed for the one, the ping will fail to this server. And we can also try and ping the other production server and see that that is also down. But both of our web servers are still going to be up because the disaster recovery side will be taking over at that point. So really no delay on this one. And you can see after refresh, they're still up.
Again, automatically failing over to that simulated WAN to the disaster recovery site. Thank you, Corey and Sam, for those great demos. And now we're going to get into some fun facts that we had our analytics department drum up for you guys. So the total hours spent on this project for us was 450 hours. We got this number by just kind of averaging the amount of time we spent per week as a team. And they found that of those 450 hours, we spent the most time on Linux containerization. It's definitely a tricky thing to get right, but once we got it right, we got it right, even though it did happen to take a lot of time. And then of that time, we also had the biggest learning curve being open switch networking, something that was completely foreign to us when we began this project, but something that we find to be very useful now that we understand how it works. And off of that, we have some lessons learned from the team. For me, I think the biggest lesson learned was working with Linux. Again, I have not worked with Linux very much in my 4 years. All we had was a couple of courses on it. And I'd say that from when I began to where I am now, I am far and beyond 200% a better Linux administrator than I was before. These guys are really good with Linux, so I had a great team to teach me, as well as the team with Dell. They gave us a lot of challenges, but they also gave us a lot of answers to help fix those challenges and to understand what we were doing with the Linux. So that for me is the biggest lessons learned, so I'll hand it off to Sam now to talk about his.
The biggest one technically was being careful at what IP address you assign to containers or other applications, because we broke down our SSH connection once because I specified a address that wasn't within our network. And for the sentimental, I'd say I'd like to thank Dell for taking us out of our comfort zone and letting us work with something new.
And the biggest thing for me, especially being at Stout, is that Cisco doesn't have to be everything. We don't need to use Cisco to accomplish some of these goals. And like they kind of said, it was really cool to work with all this new equipment, but once we finally got all working together, it was really neat to see how you can bring this open source technology together. And then once you get more comfortable with it, you can kind of figure out that if you go with something you're not exactly comfortable with, you might end up with something better than if you went with something you know.
So just in summary, at the start of the semester, Dell came to us with a few deliverables that they asked to deliver on certain deadlines. We're happy to say we met those deadlines, and as you saw, completed the project on time and to a high quality. And just reflecting, I think that when we first got the statement of work as a team, we looked at it and we said, wow, that's a lot of Linux. Wow, that's a lot of open source. Wow, that's a lot of stuff that we don't quite know what it is yet. So I'd say that it was really cool overcoming the challenge that we had. I mean, we were nervous at the beginning, but now I think 14, 15 weeks later, we can say that we are completely comfortable with the technologies that we used and the technologies that we got to play around with. And the resources that Dell gave us, the different devices and the switches and the routers, that was fantastic to use, and it really made learning it a lot easier. And with that, I'd like to first thank my team, including Dylan, who's not here. We all stuck together throughout the multiple weeks that we were working together, and there were some rough times and there were some great times, like right now. But we felt really good about the project we brought you guys today, and I'd like to thank the entire CNIT faculty, especially Holly and Sam, for making this class possible. And finally, I'd like to thank Dell for bringing us this project and giving us something new that we hadn't worked with. So thank you everyone for being here, and now we will open up the floor for questions.